In August of 2025, the skipper of Little Too Much, Rob, crewed with us on Après for Louie's last regatta, and before the race, I was showing Art and Rob a new page with some extra weather data. Part of it was a 12-hour running barometric pressure and also the current pressure. Rob said he would like this sort of data on Little Too Much, so I said, well, I could build one for you. So I already had all the components I needed. I just needed a cable and a case, which I was going to have 3D printed. And so I built it, and this video is about that.
Why you keeping me waiting? All I want, we been so long, been so long. Why you keeping me waiting? Lose trust me.
Okay, so as I said in the intro, this is an environmental sensor that puts out data on both Signal K, for Signal K via Wi-Fi, but also via CAN. So for anyone who has an NMEA2000 network, or anybody who has a ST-NG, CTOC NG network from Raymarine, this sensor would work for you. So what I'm going to do is introduce the components. So we're starting first with our old friend, the Fire Beetle. So this is a Fire Beetle ESP32E by DF Robot. Now these cost about $7, and it is basically a development board. It has a lot of capabilities. We're not going to use very much of this at all, but we will use it, and it's cheap, so we'll do that. We're also going to use one of these CAN boards. Now, these are very, very small boards. This one is made by Waveshare, and it basically does everything we need. It just outputs data via CAN and then talks to a digital pin on the board. And we're going to make some adjustments to this because it's got extra features that we don't need. So we're going to change that and modify it a little bit, but we'll do that in a minute. The next thing we're going to introduce is the environmental sensor, which is a Waveshare BME280. Now this uses the I2C interface and has basically 4 wires. It has 6, but we use 4. So we use those 4 wires there, and we will connect that to the I2C area of the board. And then we've got one of these, a little prototype board, which we're going to solder a lot of stuff on. So we're going to solder it, and then we're going to screw down into the box with that. And lastly, we have a power supply. So this is a 5-volt power supply, and we're going to connect that to the board as well. Then we have a CTOC NG spur cable. So you can see the white end of the spur cable here, and on this end it's got a raw end. So we've got the CAN high, CAN low, and power and ground on here. And that's what we need. So we need a case, and the 3D models for that are being printed over the next day, and then I'll bring it all here and put it all together. But for now, I'm going to solder this all up. Okay, so we're going to walk through the schematic. So here we have the Fire Beetle here, and all the pins of the Fire Beetle, and there's not really that much to this particular unit. So the power comes in 12 volts in here, and the ground comes in here, goes to the power board, and then out we get 5 volts. 5 volts goes to the VCC of the of the Fire Beetle, and then also to the ground of the Fire Beetle. And the ground is shared with the Fire Beetle, as well as the wave share device here, or the BME280, as well as the wave share transceiver here, which is the CAN transceiver. So these pins here are the I2C connections. So SDA, SCL, ground and power, and this is 3.3 volt power, not 5 volt power, and it goes to the wave share device, or the BME 280, which really does temperature, humidity and pressure. At this end of the board, the digital 10 and digital 11 are the two lines that go to the CAN transceiver, as well as the 3.3 volts and ground. And then from there, the CAN high and CAN low connect into the NMEA2000 CAN high and CAN low connection. So there's a few things that I want to do. Firstly, what I'm going to do is I'm going to unsolder this board here and replace it with a straight one, because I want to connect it through this board as well. The other thing I could do is just bend them back straight, which might be easier. Yeah, I've bent them back straight. They were just bent, so I bent them back straight. That was easier, just bend them back straight. Now then, this also has to come off. This piece here also has to come off, so that one I do have to unsolder. And I'm going to use a little screwdriver and get some leverage behind it while I unsolder. I also have to take the little resistor off there, because that's a terminating resistor and we won't need that. So as you can see, that's starting to come off. It's just going to take a little bit more to get it. More pressure. Okay. All right, so that's out. So now what I'm going to do is try and get that little resistor out. Yep. There you go, it's lifted right off. Okay, so that's no longer across those. Okay, so now we've soldered a lot of the pins on the bottom there, and we've connected up the CAN module here, and the ESP32 will push onto the pins here and connect up like that, really straightforward in there. And I've made it so that the USB port here is seeable over the top of the case, so the case will come up here and be able to plug in and upload software if we need to. The CAN module is also soldered in as there, and I've left enough room, I think, for the power module. So the power module is going to go on this side, and it's going to go about there. It's basically going to go on the underside. And first of all, we've got to solder some of the connections in. So the first thing I'm going to do is I'm going to set the voltage, and with these devices, and hopefully it'll focus. Where's the camera on this? You can see the voltage is on the back there. Well, one of them says 5 volts. So I'm just going to solder across the 5 volt connection, and I'm going to use a little bit of insulation tape on the back. So on the back of this part of the device here, the very top there, is going to touch the board. So I don't want anything shorting out. So I'm just going to put a bit of tape over the top of it. So it's just going to look a little like that. So it's just got a bit of tape over now. Then we're going to solder here. going to flip this over, make sure it doesn't fall out, which it just did. And it's going to go here. So I'm going to flip that. Make sure the pins are showing. And then solder the pins on. And then we have our 12 volt supply in there like so. So now I'm going to start jumpering things across. So here's the finished board. You can see the ESP32 here. You can see the CAN board here. You can see the CTOC NG wire coming off here. You can see the BME280 here. And on the other side is the power board. So there's the power board on the back right there. So that converts 12 volts into 5 volts. And then the power beetle takes the 5 volts and drops it to 3.3, which is used for the rest. It's pretty straightforward. There's a wiring diagram. You can make it as small or big as you like, but that's what that is. And then I had some pieces 3D printed. So that's the case, the top, the lid, and this is the base. So it's going to go inside this unit. And I'll show you the 3D models for this. And then this is where the sensor is going to go. It's in a little case that I downloaded the design for this one. These ones I designed myself, but this one I downloaded. And it's just for this sensor to go directly inside of. So I'm going to do that now. So we're going to take a look at the 3D models for the box that I made. So we're going to start off with the base. Now I use FreeCAD. It's free, and tutorials online that you can get from YouTube, and it's pretty straightforward. You can define all this as you need to. So what we've got basically is I defined a square that was big enough to take the board that the device was mounted to. Made sure there was enough clearance at the top and bottom. Made these turrets here so that so I could screw through the board into these turrets here and hold the device in solid. And then this groove here is for the wire, the main wire that goes to the CTOC bus. And then these 4 little grooves here were for the sensor, so that the sensor can come out. It's got little tabs here that you can bolt it down, and then it's got 3 devices or 3 little connectors here that I can screw the other half on. So what we're going to do is going to look at the other half as well. So the cap has also got some you can see what I did is I built an inner lip here. So this inner lip goes inside the other one, and it means you can put some sealant in around there and give it a seal. It's got a groove here as well for the wire, and it's got a cutout for the wire on this side. It's high enough that it clears everything, and then it's got little recesses here for the screws. So that's pretty straightforward. Now if we look at the other one, you can see that this groove here, or this recess here, will be where the sealant will go. So there'll be sealant in there, and that'll seal it up, so it's for the environment. Also, you notice that I've set it up in such a way that when the Fire Beetle is mounted in here, the actual connector, the USB-C connector, will be above the level, so you won't have to disconnect it. You'll just be able to plug the USB-C in and reprogram it if you need to. What it looks like all together is this assembly. So this is what it looks like when assembled together. The other two components are something I downloaded, and the BME280 just fits inside them. You have to use a little bit of glue to glue it all together, but that's fine. So very briefly, I'm going to go through the code that sets up the environmental sensor. So you can see all the different modules I've got installed here or included. Most of those are pretty self-explanatory. Here we define the CAN pins, the receive pin, and the transmit pin that the CAN device is on. Here we set up the initial BME280 and define some pick up, the temperature here, turn it into Kelvin here by adding 273 to it, and then read the pressure and read the humidity, and then basically they become variables here. Then we define these other variables here, so BME280 temp, relative humidity, and barometric pressure. After that, we here set up what the message would look like. What the CAN message would look like, and really set up toggling LEDs when the messages go out. And then here we have a scheduler. So basically, we define that the first message will go out after 1.5 seconds, and then every other message after that will go out every 10,000 milliseconds or 10 seconds. So when this time comes, then this code here will basically set it up so that what happens is that if the time is right, then send out this environmental parameter message, which basically is set up here. This you can look it up in the code or in one of the references, the N2K messages, and it will tell you what all these things mean. But basically, it is the PGN 130311, which combines temperature, humidity, and pressure. So we have BME temp, BME relative humidity, and BME pressure. This one here defines what sort of humidity it is and what sort of temperature. So outside temperature, outside humidity. After that, we really set up the pins here for the I2C bus, and then we start it, and this section here is all about defining parameters to send to signal K if you were going to send via Wi-Fi to signal K. Here we set up the product information. So this is the device. That's the date at which I did this. A product code, what it's called, or the model ID, and then the code number and model version. Device information is defined here, and then we're forwarding, basically setting up the NMEA2000 streams here, and that's pretty much it. There's not much to this code really. So yeah, this is pretty straightforward. So this is the finished environmental sensor. So you can see it's got the BME280 on top here in a little cage that I had 3D printed. This case here I also had 3D printed, and I built it to fit these components. Here there's a wire coming off, and the wire here goes round, and it's a C-Torque NG spur cable. And then what I've done right now is put power and ground and can high, can low to hit. And then there is a Raspberry Pi here with a terminating resistor here. And the Raspberry Pi is running OpenPlotter. And here's my signal K. And I'll basically show you this on the screen when I remote in. But basically what you can see here is that the outside humidity, the outside pressure, and the outside temperature are shown with a source of CAN 0, which is the CAN interface that is set up on this Raspberry Pi. So it's running, it's doing what it's supposed to do, and that's it. And now we're going to send this over to Little Too Much and put it on the network, and you'll be able to see it. We'll be able to see it on the Raymarine. Thanks for watching. Please like, subscribe, and comment.